Hello and welcome to the solution video to spicy question number 46. So in this question we're dealing with two regular octagons. Let's draw one of those octagons and we'll try and find its area. Let's give it a side length, let's call it L, then all of the sides are L since it's regular. Now with a regular octagon you can draw a square around the outside of it. Let's take a closer look at this triangle here. This triangle would be an isosceles triangle. The angle in the top right is 90 degrees, we know that since it's the corner of a square, and the other two angles are the exterior angles of the octagon, which we know to be 45 degrees. So, since it's isosceles, we can label the other two sides as x. Now since this triangle is right angled, we can use Pythagoras on it, so x squared plus x squared equals L squared. So we have 2x squared equals L squared. Then if we divide both sides by 2, x squared equals L squared over 2, and then square root both sides, we could say that x is equal to L over square root 2. So let's replace the x with L over root 2. Now in order to find the area of the octagon, we're going to find the area of the square and then take away all of the triangles. So let's start with the area of one of the triangles. That will be 1/2 times its base, which is L over root 2, times its height, which is also L over root 2. If you multiply these fractions, you end up with L squared over 4. And since there are 4 triangles, we could multiply this by 4 to get the area of all of the triangles as just L squared. Now what about the area of the square? Well, to find the area of any square you need its side length. So let's work out the length of one of its sides. So the length of the side is equal to L plus 2 lots of those smaller lengths which we know to be L over root 2. So 2L over root 2. If you rationalise the denominator on this right fraction, you just end up with root 2L. We can factorise out the L's here to get L lots of 1 plus root 2, and then to find the area of the square we just need to square this length. So we'll get L squared, and then this bracket squared. If you expand out this bracket you end up with this. And then to find the area of the octagon, we're going to do the area of the square, subtract the area of all of the triangles. Here we can factorise L squared, so we end up with this. And then you can simplify what's inside the bracket to 2 plus 2 root 2. We can also factorise out a 2 now, so we end up with 2L squared, lots of 1 plus root 2. So that's an expression for the area of an octagon with side length L. We're going to pop that over here because we'll need it later on. Now the question says the line MN is a line of symmetry. This means this shaded area here will be the same as the white area to the left of it. Let's try and work out the area of this blue region. So let's take an octagon, and if we draw on this line, we can see the blue region here. I'm going to draw on some extra lines as well, connecting these two vertices, and then draw on these two lines here, and for convenience I've now labelled lots of the points, because we're going to use those. We can see 3 of these lengths really easily. PQ, QR and RS are all just side lengths of the regular octagon, so they must be L. And from S to T is half of one of the side lengths, so that must be L over 2. Now let's take a closer look at the triangle SUR. Now we know the side on the right of this triangle, it's L, and the lines US and UR are perpendicular lines, so we end up with this same isosceles triangle that we had earlier. If we do Pythagoras on that one as well, we end up with x squared plus x squared is L squared, so 2x squared is L squared, so x squared is L squared over 2, and once again x equals L over root 2. What this tells us is that all of these lines here, US, PV, UR and VQ, are all equal to L over root 2. Also, in a similar way to what we did with the square earlier, we can work out the length of the line PS. PS will just be PV plus VU plus US. Now 2 of those lines are equal to L over root 2, and V to U is just L. So we end up with 2L over root 2 plus L. Once again we can rationalise the fraction here to end up with root 2L, factorise out the L, and then we end up with L lots of 1 plus root 2. Now we can use the line PS and the line ST to work out the area of the triangle PST. So the area of triangle PST is 1/2 times the base, which is PS, times the height, which is ST. If you simplify this, you'll end up with L squared over 4, lots of 1 plus root 2. Now we can also find out the area of the trapezium from PQRS. And to do this, you do 1/2 times the sum of the parallel sides, so that's QR, which is L, plus PS, and then multiply this by the height, so something like VQ or UR, which are both equal to L over root 2. The bit inside the bracket is the same as 2L plus L root 2, And then if you multiply all of this together and factorise out L squared over 2, you end up with L squared over 2 lots of 1 plus root 2. So we found the area of PST and also PQRS, so we can get the total blue area by adding these together. So the blue area equals 3/4 L squared lots of 1 plus root 2. Now we're also going to need that. If we now just look at one of the octagons, say this one here, we can work out the area of the shaded part inside that octagon, so only one of the shaded areas. So the shaded areas will be the area of the octagon take away 2 lots of the blue area. So the shaded areas are equal to the octagon's area, which is 2L squared lots of 1 plus root 2, and then if we do 2 lots of the blue areas rather than being 3/4, it'll be 3/2. So 3 over 2 L squared lots of 1 plus root 2. And if you subtract these, you'll end up with the shaded areas are equal to 1/2 L squared 1 plus root 2. So that's what each of the shaded areas is equal to. Now let's consider the total area of the entire diagram, so both of the octagons together. To do this, we'll take 2 of the shaded areas, now each one of those is half of L squared 1 plus root 2, and if we double that, we just end up with 1 L squared 1 plus root 2. And we also want 2 of the blue areas, and we did this just a moment ago, it's 3 over 2 L squared lots of 1 plus root 2. And if you add these together, you get 5 over 2 lots of L squared 1 plus root 2. Now the question asked us to work out the fraction of the diagram that's shaded. So we'll need to do the area of the shaded parts divided by the total area of the whole diagram. The area of the shaded parts is just 2 of the shaded areas, which we know is L squared lots of 1 plus root 2, and we'll divide this by the total area, which is 5 over 2 lots of L squared 1 plus root 2. Now the L squared 1 plus root 2's will cancel, this just leaves us with 1 divided by 5 over 2, which is the same as 1 times 2/5, which is 2/5. And that's the answer to the question. Thank you for watching this video, I hope you found it useful. Check out the one I think you should watch next and subscribe so you don't miss out on future videos.